This particular video is on rational exponents, and we're going to do the 101 version, or the beginning part of it. So let's think about what those words mean. Exponents, well, we know exponents are things like, say, 9 squared. That exponent would be the square, and this would be considered the base. So 9 squared, we know that's equal to 81. Now, if we think of the word rational, things that are rational basically is anything that can be written as a fraction. So the number 2 could be written as a fraction, 2 over 1. An integer like -4. -4 over 1 could be written as a fraction. It's a rational number. 1/2 can be written as it is a fraction. 0.5 can be written as a fraction. 0.3 repeating can be written as a fraction because it's 1/3. So this is basically going to talk about rational exponents, meaning I could have fractional exponents. So if I think about something that looks like this, 9 to the 1/2 power. Well, 9 squared was 9 times 9. So 9 to the 1/2 power, well, that's equal to 3. And let's think about 25 to the 1/2 power. Well, 25 to the 1/2 power is equal to 5. And 49 to the 1/2 power is equal to 7. So if we think about the reasoning behind this, well, 9 is the same as 3 squared. And if I'm raising 3 squared to the 1/2 power, 2 times 1/2 is just equal to 3 to the 1st. 25 is the same thing as 5 squared. Well, 5 squared raised to the 1/2 power, 2 times 1/2, is just equal to 1, or it's equal to 5. So that's kind of the reasoning why the 1/2 power undoes the square. Well, the other thing that we know undoes a square, like in 9 squared equals 81, something that undoes a square is the square root. So the 1/2 power, 9 to the 1/2 power, is the same thing as saying the square root of 9. So 25 to the 1/2 power is the same thing as saying the square root of 25. So thinking about that, what if I had, so we're just going to kind of look at some examples. Our goal today, our objective number 1, is to basically change rational exponents to radical form and back. So coming up with equivalent statements or equivalent expressions, some in rational exponents and some in radical form. So we learned that if I have x to the 1/2 power, I know that that is equivalent to the square root of x. So let's think about this. If I know that x to the 1/3 power, well, if x to the 1/2 power is the square root of x, then x to the 1/3 power would be the cubed root of x. X to the 1/7 power would be the same as the 7th root of x. So this denominator is the index on our root. So the denominator is the index of the radical, or root. Now notice we use two different, we use root in two different ways. We know roots of a polynomial are their zeros, or the places they cross the x-axis, but we could also talk about a square root of 9 is 3, or the square root of 25 is 5. So let's look at a couple other examples. What if I had, so let's do example number 1. What if I wanted you to rewrite in radical form? So let's start with, here are a couple examples. And so if you had, let's do 3x to the 1/2 power. Let's do 3x to the 1/4 power. And let's do negative 2x to the, let's say 2/3 power. Okay, so we're going to pause and wait for you to do those, and we'll come back. You can pause your video. All right, so we are back, and we know that the 1/2 means square root. So this is saying the square root of 3x. The 3 and the x are in parentheses, so they both have to be under the radical. Now with this guy, the 3 is not in parentheses. The only thing that's being raised to the 1/4 power is the x. So that would be equal to 3 times the 4th root of x. X is the only thing that's under the radical, so that's the reason why it's the only thing, or it's the only thing that's being raised to the 1/4 power. Now this guy is like -1 times this. So my negative is going to be outside my radical, and I know that this denominator is 3. So that is my root. It's the cubed root of 2x. Now this 2, that's basically saying if it was over 1, it would be basically saying 2x squared. So we could write this like this. Or we could write it like this. Because this part is saying 2x raised to the 1/3 power, and then it is being squared. Well, 2, when we raise to a power, we multiply the exponents. So this is saying 2x to the 2/3 power. Or we could think about it like this. This is saying 2x squared, all raised to the 1/3 power. 2 times 1/3 is still 2/3. So that's going one direction. Let's work with some numbers here. We want to go the other direction. What if you have, so now let's do example number 2. We want to rewrite in rational exponents form. So here are our 3 examples. What if we have, now we're going to do, let's start with just some, let's start with maybe the 5th root of 2x, and then let's do the 7th root of 3x, but we're going to square that. And then we're going to do 7 times the 3rd root, 5x. And then our last one is going to be 4. And let's not do the last one. Let's just do those 3. So pause your video and then practice those 3 and then come back and check your work. So if we look at this particular problem, we have 2x is under the radical, so it's going to go in parentheses. Now it's a fifth root, so according to our rule over here, the denominator, let's go ahead and write our rule. If I have x to the 1 over n power, that's equal to the nth root of x. So that's our rule. And then our other rules, if I have x to the m over n power, that's equal to the nth root of x to the m, or the nth root of x to the m. I'll rewrite those over here. We'll rewrite those again, but let's keep those kind of in our sights here. All right, so we have an index of 5, so that means we're to the 1/5 power. Now this one, we have an index of 7. 3x is under the radical, so 3x has to be in our parentheses. 7 is the index, so that has to be the denominator. And my power is 2. So I'll have 2 there. This, the power was just 1. We're raising it to the first power. That's why we have a 1 there. Now this guy right here, we have a 7 outside the parentheses because 5x is the only thing inside the radical. I'm not raising to a power, so my power would just be 1. And my index is 3, so my denominator is 3. All right, so let's rewrite our rules here. So our rules go like this. X to the 1/nth power is equal to the nth root of x. X to the m over n power is equal to the nth root of x. There's your denominator, your index. And we could write it with the m on the inside. Or we could say it's the nth root of x raised to the m power. Either one of those. All right, so part of your assignment is going to be something that looks like this. So let's look at it. So our example number 1. If we have, let's just start with 64 to the 1/2 power. So if we think about this, 64 to the 1/2 power is the same thing as square root of 64, which is just 8. Another way to think about this is, yeah, that's probably the easiest. Now let's go to another example. What if I have 16 to the 3/4 power? All right. So 4, that's going to be my index. 16, and then I'm going to cube whatever I get. So that would be equal to, well, this is 2 times 2 times 2 times 2, because 4 times 4 is 16. And I'm taking the 4th root, so the 4th root of 2 times 2 times 2 times 2 is just 2. And I'm raising that to the 3rd power, and so that gives me 8. So that's one example. Now another example would be something like this. What if you had, let's think about our negative exponents here. What if you had 1/3 raised to the, let's change that. I want to do 1/16 raised to the negative 3/4 power. Okay. Remember, when I'm raising to a power like that, I can rewrite it as 1 to the negative 3/4 and 16 to the negative 3/4. All right. The negative talks about where its position is. So if we're on the top bunk, and it's a negative exponent, that needs to go down to the bottom bunk. And this negative exponent is going to come up to the top because they both have negative exponents. So this is really equal to 16 to the 3/4 over 1 to the 3/4. Well, 1 to the 3/4 is just 1, so that really doesn't matter anymore. 16 over 1 is 1. Now, this is saying the 4th root of 16 cubed. Well, we learned in our last example, 4th root of 16 is just 2. So this is saying 2 cubed, which is just 8. So that kind of gives you a look at how we can use these radicals and we can use these fractional exponents and go both directions. So that's all we have for this lesson.